Let's examine the quadratic equation x squared plus 3 equals 0. This is a simple-looking quadratic, but it has an interesting property. To solve this equation, we would need to isolate x squared, which gives us x squared equals negative 3. But can a square ever equal a negative number? Let's visualize this graphically to better understand why this creates a challenge. We can rearrange our equation to y equals x squared plus 3. This gives us a parabola that opens upward with its vertex on the y-axis. Remember, the solutions to our original equation, x squared plus 3 equals 0, would appear as the points where this parabola intersects the x-axis. But notice something important. This horizontal line at y equals 3 represents the minimum value of our parabola. For a parabola of the form y equals x squared plus k, the vertex occurs at x equals 0. So our minimum point is at the coordinates 0, 3. No matter what value of x we choose, the y value can never be less than 3. This creates a fundamental problem for our equation. The parabola never crosses or touches the x-axis because its minimum value is 3, which is greater than 0. Since it never reaches the x-axis, there are no points where y equals 0, which means there are no x values that satisfy our original equation. This geometric visualization confirms what we suspected algebraically. Since x squared must equal negative 3, and no real number squared can ever be negative, the equation x squared plus 3 equals 0 has no real number solutions. To solve quadratic equations like this one, we need to extend our number system beyond the real numbers. This is where complex numbers become necessary. Complex numbers allow for solutions to equations like this by introducing the imaginary unit I, which is defined as the square root of negative 1. With complex numbers, we can express the solutions to x squared plus 3 equals 0 as x equals plus or minus the square root of negative 3, which can be written as plus or minus I times the square root of 3. These are called complex solutions, and they come in conjugate pairs. Here we have a quadratic equation, x squared plus 3 equals 0. This is a simple quadratic equation, but it's going to lead us to an interesting result. To solve for x, we first need to isolate the x squared term on one side of the equation. We can do this by subtracting 3 from both sides, a fundamental algebraic technique that maintains the equality. Whatever operation we perform on one side of the equation, we must perform on the other side as well. This maintains the balance or equality of the expression. Think of it like a scale. If you remove weight from one side,